Hello, and welcome to this webinar on how you can manufacture metal parts on your worktop through using additive and subtractive methods. My name is David, and I'm going to be talking you through this presentation. So, a quick look at the agenda for today. We're going to look at the benefits of worktop metal manufacturing, how we can reduce lead times, how we can reduce costs. We're also going to look at one of our new products, which is the WAZER, which is a desktop waterjet cutter that allows you to cut sheet metal, plastics, various different materials, all very quickly using high pressure water. We're also then going to look at one of our most popular products, which is the Pocket NC, which is a full 5-axis desktop CNC machine that can machine very small and complex parts. We're also going to look at a new product that's on its way into the market, which is BASF's metal filament, and how we can bring in-house metal FFF 3D printing. So, what might be the reasons that we're wanting to bring metal manufacturing in-house? So, the biggest one, I think, is reducing lead times. So we're going to go from days to hours, if not minutes in some cases, to produce high quality metal parts. This is going to allow us to rapidly prototype very quickly. And rather than prototyping a material that is not suitable or that is not going to be the end use part, such as a plastic, if the end use part is going to be metal, why not prototype the part in metal or the actual alloy that we're going to use for manufacturing? We can also reduce costs. So as we'll see later on, that the part cost can be very low and competitive with outsourcing. Finally, we're going to protect our IP, as we're not outsourcing, so there's a lot less risk of files or intellectual property falling into the wrong hands, as we're keeping all this data in-house. So, as I mentioned before, the WAZER is the first desktop waterjet cutter on the market, just running off 2 standard UK main sockets. It can cut a wide range of materials. So, for examples here, we've got stainless steel, so aluminium in there as well, marble, glass, materials that we wouldn't even really think of using before. We can also use a wide range of plastics, HDPE for instance, carbon fibre, and even soft materials like silicon. So if we just take a quick look at the specs. So we've got a cutting area of about 300 by 460. The bed size is actually 330 by 485. So we've got a bit more room there to fasten down stock material for when we're cutting. The curve size, which is the distance between the cuts outside and the cut inside, is going to be about 1.2 millimeters, and it runs off simple tap pressure water and outlets to a normal drain. As I mentioned before, it runs off 2 main sockets, and there's desktop and freestanding units. As you can see on the right, there's the freestanding unit. So we've a standard SOLIDWORKS file here. Export this by saving it as a DXF. Give it a simple name such as example plate. We're then going to pick the top face, which is going to be the top face in our DXF drawing. Quick preview, save that. We're then going to load this into the WAZER's slicing software. So what it's going to do is load in the DXF, locate it into the bed, give it a quick position and scale. We're then going to pick the material. So the WAZER comes with a variety of materials loaded into the system anyway. We're going to pick 6061, 3mm, and we're going to set the outside cut path. We're then going to automatically add a few tabs. Let's put it into the right places to keep those materials from floating around once they've been cut. And then we're going to just generate the cut file and load this into the machine. So now we've got the machine loaded and turned on. You can see it's cutting away nicely. The bubbles are showing that it's going all the way through. And we now have a finished part. So we can just take this off the bed. As you can see, there's a little bit of abrasive left on the top. A nice clean cut. So we should have a quick overview of how the part turned out. So there's a cut timer of about 16 minutes, and I'd say about a setup time of about 5 to 10 minutes, if that. We then had about abrasive, about 2.5 kilograms was used, and the rough cost of the part including the stock material and the abrasive, was around £3. The dimensions of the part was about 200 by 60 millimeters. Moving on from the WAZER, we now have the Pocket NC, which is another really good example of how we can produce metal parts on the worktop. We have a slightly smaller build volume. It comes out to around 80 to 90 cubes. We can cut materials though on here of up to grade 5 titanium or aluminium, stainless steel, nylon, wax, Delrin. Any stock material really can be held and machined in this small 5-axis CNC machine. It sets standard ISO G code, and they do include a toolpath simulator which can help make sure we're getting the correct toolpaths to machine the parts. These are a few examples of parts that have been machined on it. So we've got brass on the left, aluminium in the middle, and a stainless steel part in the center. To show how the capabilities of the machine, we did a small example part, which was this small Land Rover Defender. We used SolidCAM to program this using its 3+2 eye machining functionality. The operation you're seeing here is just a parting off operation. Prior to that, various different toolpaths were used to rough out and finish the top half of the part, where the actual body of the Land Rover is based. Following on from the part you've just seen machined, there is actually a new user interface that has just been launched for the Pocket NC, so existing customers can upgrade to this, but all new machines will be shipped with this. It's a much cleaner and easier interface to use and see. We can actually see the load monitoring now of each of the parts, so when it's machining we can actually see how hard it's pushing the machine. There's much easier, as I say, the user interface is much cleaner and easier to use, easier to set up and run manual commands. There's now a history function, so it's much easier to run repeat toolpaths. And we've simplified tool management and easier access to other various settings. So the next product we would like to talk to you about is the BASF 316L stainless steel filament that has been on the market for a short while, but is now starting to see some real traction, and we're really excited about it. What this does is it allows you to 3D print metal parts with a similar spool to what you'd expect from a plastic filament, such as the one on the right there. And what you would actually be printing is an 80% stainless steel material with a 20% polymer contact that is then sent away and post-processed for you and sent back to you with a finished part. What this does is it reduces the potential hazard of fine metal powders from SLM manufacturing methods, and it reduces the risk if you were to do the debining and sintering yourself. The material is compatible with open source FFF 3D printers, which makes it very readily available. However, if you'd like to find out if your printer is suitable, please feel free to contact us and we can talk you through the requirements for printing this material. A little bit more on how this part is actually made. So here is a great graphic that explains the process very well. So the part that we're going to be doing in-house is the 3D printing part. What this gives us is a green part. This part is quite soft, it's quite malleable, and we can actually do some post-processing. So if we need to do a little bit of sanding or taking off some small artifacts in the print, we can do that here very easily with normal tools. What this then does is we send this away, it is debinded, This is then basically going to wash away with various different chemicals the plastic components. So we said that 20% plastic is going to be washed away there. This then leaves us with the brown part. This is then sintered, which is heating it up in a chamber to basically reduce that space. So there's going to be a small amount of shrinkage to give our end part. So here we have some parts that can typically be produced using this filament. The ones on the left, you can see, have this dull sort of plasticky look to them. They're the ones which have actually just come straight off the printer. So those will need to be debinded and sintered, but that should give you a good understanding of the wide range of sort of shapes and parts you can actually produce with this technology. The two smaller parts on the right have been finished and been debinded and sintered, and they are now solid metal parts. And then the parts at the top have been polished. So this can give you a really good idea of the sort of surface finish you can achieve and the functionality of these parts. So to conclude, as we've seen, there's various different methods of forming metal parts, and there's certain benefits that I'd like to think that we've covered. That being that rapid prototyping is possible now with metal parts. So whether that be 2D parts cutting on a WAZER, or small 3-dimensional parts on a Pocket NC, or slightly larger complex parts that can be done with metal FFF 3D printing and then sent out to a much safer solution for debinding and sintering that material to then be used as an end-use part. The cost, I think we've now seen that the actual cost, particularly in the WAZER, the parts that it produces are very, very high quality and very, very reasonably priced. Reducing the time to market, all of these aspects should reduce the time that is spent in R&D and prototyping. So if we can bring that from a few weeks to a few days, this can be really powerful and reduce the time to market for the next generation of the product that we're making. The machines themselves are actually very compact now. So the WAZER, as you said, it can fit on a desktop or a benchtop. Pocket NC is very, very compact, and the Ultimaker or other FFF 3D printers are probably already existing in your company and can be utilized just by simply changing a few components and using this new material. Thank you for watching, and if you do have any questions, please feel free to head over to the SolidPrint 3D stand where we can answer any of your questions following up. If anyone would like to ask anything specific about what you've seen in this presentation, feel free to reach out to me as well on my email, which is david.dolding@solidprint3d.co.uk. Thanks very much. Everyone has a good day. Cheers. Bye-bye.